students, welcome to the next video of function. Actually, limit is not a part of function. Limit is a part of differential calculus. But you have only the concept of limit in your syllabus, okay, without any example. So we'll discuss this concept of limit under function only. So let's start with limit. Now, before actual describing the concept of limit, just consider a polygon which is inscribed in a circle. So it is obvious that as we increase the sides of a polygon, the area of the polygon approaches closer and closer to the circle, right? See, as you can see in this diagram, there is a circle, right? Under circle, inside the circle, there is a polygon. Then what I am doing, see, this is the circle. Under circle I am drawing one polygon, okay. Then what I am going to do, I am going to increase the sides of this polygon, okay. Now when I increase the sides of polygon, see what will happen. This polygon is obviously turned into circle, right? When the sides are n, there are n sides of polygon, then this polygon will look like a circle, but it is not a circle, it is a polygon which has the n sides, right? So that is the concept of limit. In limit, when I am saying that limit x tends to 2, okay, so that means value of x is very much close to 2, but it is not exactly equal to 2. So that means x will be 1.99, 1.989, then 2.0001, 2.010, right? So all the values are close to 2, but none of this value is exactly 2. That is the concept of limit. So in other words, the limit of a polygon as the number of sides of a polygon increases to infinity is a circle, right? The limit of polygon as the number of sides of a polygon increases to infinity is a circle. This can be represented as when limit of polygon. So limit of polygon is denoted by limit, L-I-M, limit x tends to infinity. X is what? X is side of polygon. Side of polygon is suppose denoted by x. So limit x tends to infinity, right? When these sides will be infinity, then this polygon will turn into circle. Clear? This is the concept of limit. In function, you have the exact value for x. Suppose f of x is equal to x square and x is equal to 1, 2 and 4. Okay, suppose x takes values 1, 2 and 4 and f of x is given as x square. Then f of 1 means 1 square, so that is equal to 1. F of 2 means 2 square, so that is equal to 4. F of 4, so that is equal to 4 square, so that is equal to 16. Okay, in function, this is the part of function, right? So in function, value of x is discrete, fixed, very clear, right? See, values are 1, then 2, then 4. Values of x is very clear. But in limit, we can write this limit as limit x tends to 2, okay, x square. That means what? Here, this is function, f of x is limit x tends to 2 x square, okay. So here x tends to 2 means value for x is close to 2, is nearby 2. but it is not exactly equal to 2. So here x will be 1.989, then 1.999, then 1.921. Okay, like this. Values of x will be like this. Then 2.001. Okay, so x values are close to 2, is nearby 2, but not exactly 2. Okay, then what we are going to do, we are going to find this function, or this is limit sum, so it is denoted by L. So L is equal to limit x tends to 2 x square. Okay, so this value can be find as, value can be, we can find this limit value by substituting x as 2. Okay, so when x will be 2, actually all the values of x are close to 2, so we consider x as 2, that is the most considerable value, right? So when x will be 2, then limit will be 2 square, means 4. Our function will be 4. So your function value, your y value will be approximately 4 or nearby 4. Since the x value is close to 2, therefore function value will be close to 4. That is the concept of limit. Clear? In function you will get the actual or accurate value. You are substituting the accurate value of function and you are getting the accurate value for you are substituting the accurate value for x and you are getting the accurate value for function. But in limit what you are doing, you are substituting the approximate value. Okay, nearby value. X tends to 2 is given, right? So in limit what we are substituting, we are substituting value of x which is nearby value, not that value. X is not equal to 2. X tends to 2 means x is not 2. Okay, x is not equal to 2, but x is close to 2. X is nearby 2. Okay, so when we are substituting x as 2, then we are getting limit value as 4, right? So function is close to 4 but not exactly 4. So that is the difference between limit and function. So next is, consider another example. Suppose y is equal to fx, okay, that is equal to 2x plus 1. Now let x approaches to 1, either from lower side, left hand side, or from higher side, that means right hand side. In both the cases, y approaches to 3, fixed value, right? See, when x approaches to 1, so when x value is 0.9, so substitute x is 0.9 in this equation. So 0.9 into 2, right? So 0.9 into 2, that is equal to 1.8, right? 1.8 plus 1, so that is equal to 2.8. So approaches to, y approaches to 3, right? 2.8 is close to 3. Then next value, see the next value, 0.99. When x approaches to 0.99, when x takes value 0.99, then 2 into 0.99 plus 1, so that is equal to, right, 1.98 plus 1, so that is equal to 2.98. Again that is approaches to 3. Okay, now this is the concept of limit. When x approaches to 0.999, then y is again close to 3. Okay, this all values are close to 1. This is known as a left hand side approach. Then right hand side approach means above 1. So above 1 is 1.1, then 1.01, then 1.001, right? But all these values are close to 1. So when we plot the graph, we get this graph. Okay, whenever left hand side from right hand side, whenever x approaches to 1, y approaches to 3. Okay, so we can write this function sum in limit form as limit x tends to 1. Okay, then equation is 2x plus 1. Okay, so we find this value as when x will be a maximum or 1. So then limit will be 2 into 1 plus 1. So 2 plus 1. So limit value will be 3. Okay, so that means in words we can say this as whenever x approaches to 1, then y approaches to 3. So in limit, in other words, the limit of f of x as x becomes closer and closer to 1 is 3. Okay, so that is the concept of limit. So with this I am concluding this limit video. In next video we are going to start derivative. Thank you students.